High-Tech Lab stands for Human-Centered, Intelligent, Interdisciplinary, and Interactive Technology. High-Tech Lab is an interdisciplinary research lab at the University of South Carolina that specializes in creating human-centered experiences in education, healthcare, and technology. Dr. Dezhi at USC, the founding director of High-Tech Lab, leads multiple sponsored research projects in the lab, primarily focused on human-computer interaction and artificial intelligence. Today, we will be presenting a demonstration of the ALLURE platform that our lab created, an AI-driven multimodal platform for users to learn how to interact and work with AI through explainable AI scenarios, and a chatbot for solving the Rubik's Cube in a collaborative learning environment. Our system consists of an automatic solver, Deep Cube, based on deeper reinforcement learning, and an explainable module that uses inductive logic programming. It also has an interactive chatbot built with Raza platform and keeps tracks of users' learning goals and progress. The ALLURE platform is intended to provide users with multiple modes of input and output to learn from the platform in the way that works best for them. In the center of the platform, the user can see a 3D model of a digital Rubik's Cube and visualize its 6 faces and their movements. On the right side, we have our chatbot, ALLURE. ALLURE will teach users how to solve a Rubik's Cube problem called the white cross for the given scrambled state of the cube. Before moving on to solving the cube, the tutorial teaches users all of the basic conventions of the Rubik's Cube. We at High-Tech Lab want to thank everyone for their hard work and contributions to the ALLURE platform. Likewise, we would like to acknowledge the generous funding provided by Aspire 2 grant at the University of South Carolina. We would not succeed without this support. Thank you. The tutorial is optional for users to become familiar with the ALLURE platform. Each flat surface of the cube is considered a face, and each face is a different color. Here we introduce the faces highlighted as mirrors. This consists of the left, back, and down faces. Next, the front, right, and top faces. Along with different faces, it has 3 different types of pieces: a corner piece, an edge piece, and a sticker. Each different cube face is represented by a letter, and those letters are used to define the clockwise and counterclockwise moves of those faces. The faces and their corresponding letter representations are F for the front face and B for the back face. Next, users are introduced to the chatbot. Solving a Rubik's Cube consists of various subgoals. The subgoal we'll be solving in this demo is the white cross, which involves getting the white orange, white green, white red, and white blue edge pieces in place. The white cross is the foundation for learning how to solve a Rubik's Cube. The chatbot provides a comprehensive guidance for users to solve the white cross through different explainable AI scenarios users can solve and interact with. Each explainable AI scenario will provide the user with a situation they may find when solving the white cross and help them achieve it. In this scenario, the user will be provided an explanation in the chatbot to solve this given situation, which they then can use to visualize the 3D Rubik's Cube. The explanations provided are structured in a manner to teach users to problem solve. First, the chatbot will identify where the piece is that they wish to move in relative to the goal state. Then it will explain how the piece will need to be moved to reach the goal state. And finally, it will provide the shorthand text so the user can learn how to verbalize the movements. The chatbot will also provide encouraging words throughout the interaction. In scenario 1, the user is given a situation in which the front face needs to be aligned in order to make the white cross. Users can choose to rotate the cube while utilizing the tools provided by the platform. By clicking the reset view, they can return to the original orientation. The F move piece needs to be utilized to solve the white cross. By resetting the cube, the platform will reorder the pieces in the original scenario placement. Then the user can select the Solve button when they are ready to continue. In scenario 8, the user is introduced to an example situation that builds on a past scenario. In this case, scenario 5. The user is prompted to build upon this knowledge when solving the scenario. The user will use scenario 5 to put the white-green edge piece in place. Rewind and forward buttons undo and redo the moves by the chatbot. Once the user is done, they will click Solve when ready and move on to the user task. The ALLURE platform is designed to give users the freedom to personalize the learning experience on the platform so they can learn at their own pace using ALLURE as an AI-enabled learning tool, which is why it is designed with many interactive features in the platform for users to independently explore different ways to solve the Rubik's Cube. The speed slider, located on the top right corner, allows the user to speed up or slow down the movements of the Rubik's Cube. For example, if the user is learning a new scenario, they may want to slow down the Rubik's Cube movements so they can better understand how the faces change. Once they have watched the scenario, the user may want to try this move on their own and choose to speed up the movements of the cube to expedite the process. If the user wishes, they may revisit the tutorial by clicking the tutorial button on the top left corner. Here, they can watch the explanation of the faces and pieces of the cube to relearn or recall what they are called. Additionally, if they are struggling to understand the chatbot explanations, they can restart the chatbot experience by clicking Chatbot Tutorial. The user can access a quick reference guide to the scenarios they learned from the chatbot by clicking the Scenarios key. The Scenarios key provides a condensed version of the scenarios and explanations given in the chatbot. When the user hovers over the scenario number, they can see the initial configuration. And by hovering over the movements, they can visualize how to solve the scenario without scrolling through the chatbot. The Moves button allows the user to quickly reference all the moves that are available to them to solve the cube. The Moves key is provided so the users can understand how the faces of the Rubik's Cube can be moved. Additionally, they can visualize each rotation on the 3D Rubik's Cube by hovering over a particular movement. The user can perform movements on the Rubik's Cube by using the Moves buttons located below the cube. Each of these buttons provides a shorthand of the Rubik's Cube rotations and allows the user to explore how the Rubik's Cube faces move and solve the cube independently. When the user hovers over one of the Moves buttons, an arrow appears to indicate the direction of the movement it will make. And when the user clicks on one of the Moves buttons, the section that it is moving is also highlighted to help the user visualize how the face rotates around the cube. Once a user feels comfortable with the platform, they are then asked to complete a user task to test the knowledge that they just learned. To begin the user task, users are prompted to click the User Task button located on the bottom left corner. The task is to complete the white cross from a provided scenario, as the user learned from the scenarios in the chatbot. The user has the option to complete a practice task first to help the user feel more familiar with moving the cube. The platform will ask the user to perform a series of movements on the Rubik's Cube, such as right face clockwise, and the user is able to test their knowledge of the shorthand movements. Once the user has completed the practice task, they may continue to solve the user task. The platform provides a scrambled Rubik's Cube. If the user wishes, they can refer back to the image of the goal state, the white cross. Additionally, they can reference the scenarios or movements that they learned on the platform to complete solving the task. Once the user has completed the user task, the platform will congratulate them.